is right now, is there flux through the loop?
No.
No. Okay. In a little bit, will there be flux through the loop?
Yes.
Yes. And will that flux through the loop be into the page or out of the page?
Into the page.
Into the page. In other words, which direction are the field lines going through it? They're going through it into the page, okay? Or in this case, into the board. Okay? Everybody get the idea?
Yep.
Is that flux going to be at least... Okay?
Thank you.
Is that flux going to be increasing, decreasing, or staying the same?
Increasing.
Increasing. At least until the whole loop gets inside. Okay? Does that make sense to everybody? So, what this negative means is that my loop does not like the flux through it to change. Okay? It does not like the flux through it to change. It wants the flux to stay the same. So in other words, your loop is like a person. It doesn't like change. Okay? So as it goes in, so it's now a little bit into the thing, what's happened to the flux?
It's changing.
It's changed it. It's gone up. It doesn't like the flux going up. Please note, it's not saying the field is changing, it's saying the flux is changing. It doesn't care about the field, it doesn't like its flux changing. Which is the reason I did this problem, because the field is exactly the same, always. So the flux has increased. Everybody agree?
Yes.
The loop says, I like the flux to stay the same, which means I need to somehow decrease the flux. Okay, everybody with me? Okay, so in other words, well, the flux originally was 0, and now it's increasing. I want it back to 0, which means I have to try to get rid of it. Okay, and the only way to get rid of flux that's increasing with more field lines going into the board is to create field lines that come out of the board. Okay, everybody with me? So, I have to, using my right-hand rule, I have to figure out what direction the current's going. Well, the current's going to go so that the field lines created by the current come out, at least in the middle, in the region where there's going to be flux. Well, so, is it going around this way? No, because that would create field lines
into the board.
Into the board. Okay? But if current were going around this way, that would create field lines coming
Out of the board.
out of the board. So that means in my loop, my current is going around in that direction. Because it's not trying to change the field, it's trying to change the flux. And the flux is increasing, so it wants to keep the flux the same. So it creates a current that tries to oppose not the field, not the flux, but the change in flux. See how one little -1 sign can mean an awful lot?
So it basically just say that they would try to create a field line that go the
No.
opposite way.
It's trying to oppose not the field,
The change.
the change
Change
in
in
the
flux.
Okay? The field is almost irrelevant. What matters is the change in the flux.
And that loop is the current that's induced because of the change in flux.
That's right. Because it wants to keep the loop wants to keep the flux at the same value. So if the flux is increasing, it creates a current to try to do what to the flux? Decrease it. Okay, now, in the middle region here, as it travels through here, it's all in here. What's the flux?
0.
No.
Or no, constant.
Constant. So is the flux changing?
No.
No. So do we have any induced current?
No.
No. Now we're over here, though. This is where you have to really start thinking. This is where it gets cool. Is the flux increasing, decreasing, or staying the same now?
Decreasing.
Decreasing. Everybody agree with that? Okay. It doesn't like, what does the loop not like? Change. So does it want to try to increase the flux this time or decrease the flux this time? Increase it. So does it want to create field lines in the same direction or the opposite direction?
Same direction.
The what?
same direction cái one increasing.
Yes, it needs to create field lines in the same direction because it wants to keep the flux the same, but the flux is going up or down? Down. So I have to create field lines that go into the board in this case. Okay, everybody with me? So in that case, the current's going around in that direction. Okay, so in this case, the current created a field that was the same or in opposite directions of the field. Opposite. Because it's not opposing the field. What's it opposing?
Change in flux.
Change in flux. Okay? Which is the reason is people say anything about, well, what about the... No, the field is irrelevant. What matters is the change in the flux. It wants to keep the flux the same. Because over here, the flux is doing what? Decreasing. So it wants to make the flux go back up. And the only way to do that is to put field lines in the same direction. Okay? Now, if you go back to our very first experiment where we started doing this, as the magnet came towards the loops, what was happening to the flux? Was it increasing or decreasing?
Increasing.
Increasing. And we got current in one direction. And as it went through and started falling away, the flux started decreasing, which means it's going to create current in the
Opposite direction.
Did you remember seeing that?
Yeah.
Kind of cool. Okay? Everybody with me? So, I need you to pull out those pages we've been doing. Okay?